Hello everyone, my name is Dylan and I'm here to walk through the 2024 SATs papers. They've been released, they're on the government website, and I'm going to walk through every single paper for you, starting with the maths papers, and of course in this video starting with the arithmetic. So let's see what was involved, let's see what questions there were, and let's see exactly how to answer them. Starting with question 1, 689 plus 38. Again, the best thing to do here is you've got plenty of time in this test to do this. Just line up the digits with your plus symbol, plus 38. And there's lots of you shouting at the screen now saying, oh, I could probably do this mentally. Sure, but I like to just make sure 17 is 9 plus 8. 8 plus 3 plus 1 is 12. Cross out the one I've added and exchange over. 6 plus 1 is 7. The answer to the first question was 727. Next one, 72 divided by 3. Again, you may well be able to do this mentally, but I like to use short division method, or what's also known as the bus stop. How many 3's go into 7? 3, 6. That's 2 3's with 1 left over to get to 7. So that one gets exchanged, 3's into 12, 3, 6, 9, 12. You can simply count up and get 24 as your answer. Again, you might be able to do these first two mentally, but there's the written method anyway. Another simple one here, 23 multiplied by 6. Again, there is a mental method. You could do 3 times 6 and 20 times 6 and combine them in your head. This is basically what's going on here. I'll just write down short multiplication. 6 3's are 18. Exchange over the 1, and then 6 times 2 is 12. Add the 1 is 3. So I have 138. Quite a nice start to these papers. Question 4. 4,532 take away 19. Now you could do the column method. I'm going to show you a mental method here. Subtracting 19 is the same as subtracting 20 and then adding 1 back on, because minus 20 plus 1 is minus 19. They're the same thing. So taking away 20 from 4,532 is much easier because we end up with 4,512, taking away 2 10s. And then I'm just going to add that 1 back on. We get 4,513 as our answer. A nice little mental strategy there. Question 5, 3 multiplied by 391. Again, it doesn't matter what order you multiply in, so I'm going to swap it straight away and do 391 multiplied by 3. Just going to put it in the short method just to make sure. 3 1s are 3, 3 9s are 27, exchange over that 2. 3 3's are 9, add the 2 is going to give us 11. We have 1,173. Nothing spooky so far in this paper. Question 6, again, they're just simply trying to show you questions in a different way to try and spook you out. It doesn't matter that the question's on the right and the answer box is here. We still just have to complete this question. 9,171 take away 530. Just to make sure I always write it out like this. This is something you could, again, do mentally because you know you're not taking away any 1s. You're going to take away 3 10s. So that's 4 10s. Obviously, that 1 stays there because we take away nothing. 1 take away 5, we're going to have to do some exchanging here. It's why writing it down might help. 11 take away 5 is 6, and then we just have 8 left over. So we put our answer up here. 8, 6, 4, 1. You'll notice in the other questions, there was a little box in the corner. We put our answer. You can see that there. Not for this one, it puts the box in the question. Just a small thing trying to trap you. But, you know, maths is simple. So you just put your answer at the top. 6,600 divided by 6. You should use your times table facts here because you should be able to know 66 divided by 6. If you know your 11 times table, 66 divided by 6 is 11. But then we have 2 placeholders, which makes the answer 100 times bigger too. 1,100 is the answer. This is a very interesting question because when we multiply by 1, the answer just stays the same. So we can basically ignore that multiply by 1. 99 times 10, well, we're going to have 99. Shift it up 1 place and then put a placeholder at the end is 990. Remember that times 1 doesn't really do anything. The number stays the same. Classic SATs question here with 2 numbers that have a different number of decimal places. We have 2 decimal places in the first number. We're going to add 13. What do you notice straight away? Yeah, I'm going to rub this out because 13, if I was to start writing it here, the decimal would go into the wrong place. No, 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 no. So if you're going to put the larger number on the bottom, just make sure you have space because the 1 would have to go into this column with 13 point, making sure those decimals line up, which they do nicely. 493. So this question's all about testing, can you line up those decimals? Up here we have nothing. We could put a placeholder. And now we're going to add them. 0 plus 3 is 3. 8 plus 9 is 17. 6 plus 4 is 10. Plus the 1 is 11. Remember to drop down that decimal. We've added on that one there. 7 plus 3 plus 1 is 11. Again, get rid of that 1. 1 plus 1 is 2. And we've got 21.173 as our answer. It's a straightforward question. The trick there was just laying it out. 9 times 752. Again, they've just swapped them. Just anything they can do to try and trick you guys into thinking, oh, what do I do here? It doesn't matter. It's the same as 752 multiplied by 9. You need to know your times tables. 9 multiplied by 2 is 18. 9 multiplied by 5 is 45, plus the 1 is 46. Get rid of that one. 9 sevens are 63, plus the 4 is going to be 67. and you get the answer 6,768. Again, nice and straightforward if you know your times tables. Question 11, 640 divided by 8. Again, use your times tables. 64 divided by 8. You should know that that is 8, but 640 is 10 times bigger, so our answer is also 10 times bigger, which is 80. If you wanted to check, you could then multiply the answer by 8 and end up back at what you started at, which should be 640. Look, this is just peppered with these just different ways of showing the question, isn't it? It's very interesting. 357 take away 89. Again, you could just do column method. Do you know what I would do here? I'd do 357 take away 90, because I can think of 9 tens, take away 35 tens, take away 9 tens. That leaves me with 26 tens, so 267. However, I took away one too many because I changed 89 into 90, so I need to add one back on. That gets me 268. If you did column method, you still get the answer, wherever you're more confident in. It doesn't really matter as long as you get the correct way at the end. 561 divided by 3. Again, it is just begging for you just to whack this into short division to make sure. How many 3s are in 5? Well, if I've got 5 dots here, I can make one group of 3 with 2 left over, so the 2 gets exchanged. 3s into 26, counting your 3s, get as close as you can without going over 26. We end up with 24. 8 3s are 24, and that would leave 2 left over. And luckily for us, 3s go exactly into 21 7 times. So it looks like we've got this question bang on with 187. Aha! 4 6 multiplied by 1/8. Well, if you know how to multiply fractions, this question is very simple. Multiply the numerators together, you get 4. Guess what? Multiply the denominators together, and that's it. So you need to know times tables. 6 times 8 is 48. So we could have 4 out of 48. You could simplify it if you wanted to, because 4 out of 48 is equivalent to 1 out of 12. You could divide the top and bottom by 4. Either way, do you know what? It's the same answer, so it doesn't really matter. You'd still get the mark. 630 divided by 7. Look, they put the answer at the front again. It's like they're almost exclusively doing this just to trap you, but it doesn't matter. We know that. 63 divided by 7. Again, know your times tables. You'd know that's 9, but it's 10 times bigger. So it's not 9 as an answer. It's just 90. We've seen 3 of these questions now where you just need to know your times tables with powers of 10. Ooh, this is a place value question. You don't need to do any working out because we've got 6 million plus something plus 70. Equals 6,020,070. Literally saying the number out loud makes it pretty obvious what we're missing. 6,020,070. Well, we've got the 6 million and we've got the 70. What did I say? 6,020,000. That's it. That's what we're missing. 20,000. It's just testing, can you get that right amount of place value holders at the end? You need 4 zeros after the 2 for 20,000. The trick here is you might just write 20 or even 200. That would be incorrect. You need 20,000. Say the number, best way to do it. This is such an easy question. This is from the Year 4 curriculum, but it's just designed to try and catch you out because there's 2 rather large numbers here. When you multiply by 1,000, 1, 2, 3 places, you move up the digits. So we end up here with a rather large number into the millions, 2,671,000, and then 1,000 at the end. Again, if you just say this out loud, 2,671 times 1,000. So we know we're making it 1,000 times bigger. We just shift those digits up. Nice and straightforward. 5/12 plus 1/3. When we're adding fractions, we need to make the denominators the same. So luckily 3 goes into 12. So let's convert that. 3 times 4 is 12. So we're going to do the same to the top and we get 4/12. Now we simply got a case of 5 plus 4. That gives us 9/12. Again, you could simplify if you wanted to 3/4, but 9/12 would still get you the mark because it is correct. 2/3 plus 4/5. It's the same question as before, but we don't have a denominator that can easily go into the other one. So what do we do? Well, we just multiply them together. So 3 times 5, that's going to give us 15. Do the same to the top, it gives us 10, because 2 times 5 is 10. Plus, well, 5 times 3, that's also 15, which means the denominator is the same, luckily for us. Do the same to the top, so we're going to do 4 times 3, which is 12. And then we get 10 fifteenths plus 12 fifteenths, which is 22 fifteenths. Again, you have the option here, if you're confident with your fractions, you could write down 1 whole with 7 fifteenths left over. But both are correct. Both are the right answer. Aha, our first long multiplication. But luckily, it's just by 14. So when we do long multiplication, we're going to times it by 4, and we're going to times it by 10, and then we're going to finish off by adding up those 2 answers we get. So let's do 6,312 times 4. 4 times 2 is 8. 4 times 1 is 4. 4 times 3 is 12. So that's 1 left over there. I'm going to put it at the top so it's out of the way. 4 times 6 is 24. Plus the 1 is going to be 25. So that's 4 lots of the number. Now we're going to work out 10 lots, which is so easy because we just put a placeholder and then literally copy the digits in because it's 1 times. And then to find the answer here, we're going to add them up. we get 8 in the ones, 6 in the tens, 3 in the hundreds, 8 in the thousands, and 8 in the 10,000s, 88,368. Whew, we're over halfway through. Let's keep going. 2 plus 3 to the power of 3. This is bid maths. This is order of operations because you can't do 2 plus 3 first and get 5 and then cube it. You have to do this cubing first. So 3 to the power of 3, what is that? Well, that is just 3 written out 3 times, multiplying them together. 3 times 3, that gives me 9, not 6. We're not adding. That's a very common misconception. 3 times 3 is 9. Then we've got to multiply with 3 again, which gets us to 27. So 3 cubed is 27. So I can literally swap that in. Now I've got 2 plus 27 because you do your addition at the end. You get the answer 29. It's order of operations. Need to learn that. We've done a whole video on it. Go and check our channel. We've got loads of SAT stuff on there. 15.5 divided by 100. 15.5 divided by 100. Cool. So what we're going to do here is move the digits down 2 places and keep the decimal in the same place. That's how it's so easy now because it's got 2 placeholders and we're getting smaller. This first 5 goes 1, 2, goes into this column. This second 5 goes 1, 2 into the hundredths column, and the 1 goes from the tens column down to the ones and then down to the tenths. Just there, 0.155, which means we put a placeholder at the front, 0.155. Notice those digits don't change. When we multiply and divide by 100, we're going to keep those digits just somewhere else on our place value chart. Another order of operations questions, we have to do division first. 56 divided by 8, that is 7. So I can literally swap that in. 90 take away 7 gives me 83 as an answer. If you did 90 take away 56 first, you will end up with the wrong answer. You get 34 divided by 8, and that should ring some alarm bells. That doesn't quite work. Question 24, a whole number subtract a decimal. Again, a very common type of question. No decimal there. What am I doing? 63, take away 5 in the ones column, then the decimal goes after, 5.8. So you're thinking, well, how do I do this? You can just put a placeholder in. Put a decimal after the 63 and put 0.0 because 63.0 is the same as 63. 0 take away 8 you cannot do. It is not 8 because we've got nothing. You could say, well, 0 take away 8 is minus 8. Of course, but in the context of column subtraction, we're going to have to do some exchanging. So we get 10 tenths, take away 8 tenths, leaves me with 2 tenths. Decimal goes in. 2 take away 5, again, we're going to have to do some exchanging here. 12 take 5 is 7. 5, drop it down, we get 57.2. 57.2. Again, you might have done take away 5 and then take away 0.8 in your head. If you're more confident with that, that would still get you the same answer. Doesn't matter. Aha, another long multiplication, this time with slightly trickier numbers. We've got the 7 times table, which will always come up, almost guaranteed, because it's one of the trickiest ones to learn. 7 eighths, that's going to be 56. The way I remember that is 5, 6, 7, 8. 56 is 7 times 8. 7 times 1 is just 7, plus that 5, that gives us 12. Exchange over the 1. 7 fours are 28, plus the 1 there is 29. Now we're moving on to multiply by 40. Put a placeholder in, so now I can just multiply by 4. 4 times 8 is 32, so exchange over the 3. 4 times 1 is just 4, plus the 3 is 7. 4 times 4 is 16, and then we have to combine them to get our answer. I'm going to write it straight in. 6 in the ones. We've got 4 there in the tens column. 9 plus 7 is 16 in the hundreds. Exchange over. 6 plus 2 is 8, plus the 1 is 9 in the 10,000s, in the thousands column, and then there's just 1 left over in the 10,000. 19,646. Quite straightforward if you know the method. 6 sevens take away 11 21sts, I think we'd say. Luckily for us, 7 goes into 21, so we only have to change one fraction here. Multiply the bottom by 3, so do the same to the numerator. 6 3s are 18. That leaves us with a simple question now of whether denominators are the same. So we just do 18 take away 11. That is 7 out of 21. Again, we have the option to simplify here. We could put 1 out of 3. We could divide the top and the bottom by 3, but 7 out of 21 is still correct. Ooh, 7 over 10 divided by 2. Now we can just very quickly, if we know how to do this, we can change it into a multiplication, which is 1 over 2. Okay. Now it becomes so easy. If you know how to make this transformation, this question is really easy. If you don't, check out our videos, we can teach you how to do that. But all you need to know is that you can flip the number, make it 1 out of 2, and now we can do 7 times 1 is 7, 10 times 2 is 20. Okay, so this is half the size of 7 tenths, 7 20ths. Next one, 2 and 3 eighths take away 5 eighths. Now, classic. What I'm going to show you is a method where we split 5 eighths up. We're going to take away 3 eighths and then take away the remaining 2 eighths, because altogether we've still taken away 5 eighths here. But why would I pick 3 eighths first? Well, because it cancels out in this mixed number. So then we're left with 2 take away 2 eighths. Now we know there are 8 eighths in a whole. So if I take away 2 eighths from 2, I'm left with 1 whole and then 6 eighths left over. 1 whole and 6 eighths, because if I add back on the 2 eighths, I'd have 1 whole and 8 eighths. I know 8 eighths is 1, so that makes it up to 2. Again, look, 6 eighths could be written as 3/4. Lots of options here to simplify, but trust me, you don't have to. This is still correct, okay? This is still a right answer, but if you're going to actually write it down, 1 3/4 is absolutely correct. It's the most simple form, okay? That's the most simple form. Question 29, 0.7 multiplied by 26. My method for this is to turn 0.7 into just 7. So I'm going to do 26 multiplied by 7. And you're thinking, that's not the question. No, I know, but you'll see what I do at the end. 6 times 7 is 42. 7 times 2 is 14. Plus the 4 is 18. Do you notice how important it is to know your times tables? I hope that comes through, guys. You really need to learn them. Now we've got 182. So we'd be very tempted to put 182 as our answer. But we get it wrong, even though we've done some really good maths here. Because we multiplied 0.7 by 10. So everything we've done here is 10 times too big. So at the end, we're going to have to divide by 10 to end up with the right answer, which means the decimal just goes here and we have 18.2. That's the right answer. Oh, long division. Again, now we're dividing by 34. So a very common technique when we're doing long division is to write down on the right-hand side your multiples of 34. You can keep adding 34 if you like. So 34 plus 34 plus 34 here is 102. Let's see, that should be enough for now. Okay, so how many 34s go into 9? None. So let's do 34s into 98. We can do 2 lots, which is 68. Cool. And that we're going to take that away there. So we end up with 30. So we can write a 2 here because 2 34s make 68, but we have 30 left over. We're going to drop this 6 down because what we have now is 306 left. Well, I noticed something. 3 lots of 34 was 102. That means that 6 lots of 34 is 204. That means that 9 lots of 204, we're going to combine these together and we get 306. Can you see that pattern here? 369. Oh, 369. We're going to add another lot, add another lot. We end up with 306. So I know that 306 exactly is 9 lots of 34. And that leaves me with 0 remaining. And I've got 29 lots of 34. And that's my long division. 2 marks for that question, I believe. Yeah, 2 marks always for those short division questions. So show you working out. 99% of 600. I love this question because really a quick method here, just find out 1% of 600. 1% of 600, we're going to divide it by 100 and we get 6. Why do I need to work out 1%? Because it's really easy and because what you can do now is just take away 6 from 600 because 1% less than everything is 99. So the answer here is 594. If you worked out 10% and 1% and then multiplied them both by 9, you take forever. This is a lovely little shortcut to get to the answer more quickly. Just work out 1% and take it off. 1/2 divided by 3. Again, this is a really, really easy question if you know that you can write it as 1/2 multiplied by 1/3. Because now we've got 1 times 1, 2 times 3 is 6. So lots of this paper can be unlocked by just learning some methods. We've gone through lots of methods on our channel, so do be sure to check those out. Question 33, 43% of 900. Now this is something where there's less obvious of a trick. So I would be working out 10% and I'd be working out 1%. And if I do this, I can work out any percentage by just using building blocks. 10% of 900 is 90. 1% of 900 is 9. Cool. Well, I need 4 tens because I've got 40%. So let's times that by 4. 9 times 4 is 36, but it's 10 times bigger. So 40% is 360. 3%, so I need 3 lots of 1%. 9 times 3 is just going to give me 27. That gives me 3%. So 43%, I'm going to add these together. I'm going to get 7 in the ones, 8 in the tens, 3 in the hundreds. 387 is 43% of 900. 2 1/6 take away 2/3. Okay, firstly, straight away, make the denominators the same. So we're going to be taking away something sixths. How do I go from 3 to 6? Well, I multiplied by 2. Do the same to the top. And now I've got 2 1/6 take away 4/6. Again, multiple ways to do this. I'm going to show you a different way now, where I change this mixed number into an improper fraction. 2 wholes. Well, 1 whole is 6/6. So 2 wholes will be 12/6. So I'm going to change and swap this 2 for 12/6 plus this 1. So this is equal to 13/6. Take away 4/6. Now it's very easy. Just 13 take away 4. End up with 9/6, which written as a whole number is 1 3/6, which simplified is 1.5. So lots of opportunities for simplification here. 1.5 absolutely is the right answer there. Question 35. 1 1/4 multiplied by 39. Straight away, I'd be splitting this up. 1 times 39 is just 39. So now we're going to add on 1/4 times 39. A few ways you can do this. You basically are dividing 39 by 4. That's what's happening here. Or you can think of it as 39 over 4. Okay, so the question becomes, how many whole numbers are there in there? Well, every time we have a 4, that's a whole number. So this is the same as 9 whole numbers, which is 36 over 4. 36 quarters is 9 wholes, plus the 3 quarters left over. So we have 9 3/4, Harry Potter, 39 plus 9 3/4. So 39 plus 9, that gives me 48, and I've got that 3/4 left over. Very interesting question. You can just split it up, multiple ways to get there. Let me know in the comments if you did a different method. Question 36, this is the last question. Oh, let's get it done, shall we? So 73, very tricky one to end with because we need to do multiples of 73, classic. 73s into 42 don't go, so we're going to actually be trying to go up to 423 here. So let's see how many multiples we can write down. 73, double that is 146. Now add on another 73, we get 219. Okay, you might have to work this out. Okay, I can do this in my head just because I'm used to doing this now. So add another 73 onto this, we end up with 292. Add on 73 there, so we'd have 89, add on the 3, that's why I've got 292. At this point, you might be thinking we can think of some shortcuts on how to get to different amounts, because that's 4 lots. So what would 5 lots be? Well, again, if you think 6, 7, 8, 9, let's write 10 lots down here. 10 lots of 73 would be 730. So 5 lots is half of that. So if you're good at halving, you can half 700, which is 350. Half 30, which is 15. We get 365. Again, you might be shouting at me going, I know how to do that. I can add on 73 there. Cool, that's fine. No problem. 6 lots. Again, we need to get to 423. We're getting close, but let's just do one more and see if we're there. Well, 6 lots is actually double 3 lots. So we can take 219 and just double it. And we get 400. And what's double 19? We'll do double 20. Because that's close, so that's 40, then take away 2, we get 438. That's too much. So we're going to have 5 lots fit into 423. That is 365. So let's take that away. 3 take away 5, we're going to have to do some exchanging. 13 take away 5, they're not going to make this easy, are they? This last question. 1 take away 6. Okay, well, we can't do that, so we're going to have to do some exchanging again. 11 take away 6 is 5. And then 3 take away 3 cancels out. So we're left with 58. Well, what do we do now? We have to drop this 4 down. So we're actually left with 584. Okay? Cool, no problem. We're going to have to keep going, aren't we? So, again, what about 7 lots? Well, let's just add on 73. Probably the best way to do this. We're going to get 500 and add on 70 gets us 508. Then add on the 3 gets us 511. Here we go. 8 lots, add on 73, which is really easy here. Add on 70 gets me 80. Add on 3 gets me 4. Yes, 584. That is exactly 8 lots. And we can do this to make sure there's nothing remaining. Of course not. 8 lots of 73 is 584. This is where our multiples are really simple. And the answer is 58. And that is the end of the 2024 Year 6 Key Stage 2 SATs Arithmetic Paper. Guys, stay tuned. We're going to be releasing the 2 problem-solving reasoning papers very, very soon. Let me know in the comments how you think you got on. How many of those questions do you think you could get right? Were there any that were really tricky? And do you have different methods to me? I'd love to read about it. Catch you next time.